Welcome friends. We all know that the real estate prices are going up always. Okay. There is no space the big cities to grow horizontally. The big cities grow in fact vertically. How about having a house in space? So imagine a house in zero gravity always floating far off from the mother earth. Is that possible? Is that possible to have floating cities? Is that possible to have your own house in a floating city far off in the space? This is the dream of everybody, every human being. Okay. So the scientists say that it is possible to have your own floating house at the space and our own floating cities in the space. There are certain points in the space where the gravitational force between two big mass objects like sun and earth, they become zero. At those places you can have a floating city, they say. What are these points called? These points are called the Lagrange points. Okay. So first it was proposed as a three-body problem. Okay. So the mathematicians and scientists, they worked on a three-body problem. What is a three-body problem? Take a very massive two bodies, okay, like sun and earth, and take a third body which is very, very small, very minuscule. It is, okay, just a few 100 kilograms or so, like that. Is that possible to place that third mass somewhere within the orbit of the sun and the earth? They thought like that. So, and mathematically Leonard Euler and Joseph Lagrange have proved that it is possible. Joseph Lagrange and Leonard Euler were contemporaries. So what happened was that Leonard Euler worked on this problem and he found 3 of the 5 points, and it was and they were named as L1, L2 and L3. They are in a straight line between sun and the earth. L1 is a point that is about 15 million kilometers from earth, between sun and earth, and this is called the L1. And L2 is a point that is beyond the earth, that is the L2 point always points to the night side of the earth, while the L1 point always points to the day side of the earth. Okay. And there is one more point also which Euler found out, that he named it as L3. Where is the L3? L3 is beyond sun. We cannot see that. Okay. And for a long time it was thought that there is a planet X there, and the inhabitants in that planet X were in war with us. They will somehow come over to Earth and they will destroy Earth. That was the kind of rumors, or that was the kind of stories that the science fiction writers spun out. So that is it. But one thing is this L1, L2, L3 are all very, very unstable points. So of that, L3 is the most unstable point. But to come at this conclusion, to work on this three-body problem, Lagrange or Leonard Euler, they made certain assumptions that what would happen if these 3 points are stationary and there is no other external influence affecting the orbits of either sun, earth, or that minuscule third particle, third mass. Okay, so these assumptions they had made. So that assumption is still valid, and based upon some assumptions only we can try to find a solution. But in the real world it is not exactly the three-body problem. There are multiple factors which influence the orbit of the earth, moon and other planets, etc. For example, L3 at some places about once in every 20 months comes very near to the orbit of the Venus, and the orbit of the Venus gravitational force destabilizes that L3 point. By the way, can we see the L1, L2, L3 with our naked eye? No, we cannot see them through our naked eye. With the powerful telescope, you can, even with the powerful telescope, you can only see the region where the L1, L2 and L3 could be. And of that, L3 we cannot see even. And NASA once sent a spacecraft to photo the beyond the sun to take a photograph of the L3 region, and through the photograph they conveyed the message to the common man that L3 region is empty and there is no planet X. Okay, that still has got some science fiction value, but we cannot see these regions because these are very unstable points, and nothing, no object is going through there. But what it is useful for? Before seeing what it is useful for, I request you to kindly subscribe my YouTube channel to see these kind of videos. Okay. Now going into the subject, what did Joseph Lagrange find out? As I said earlier, Leonard Euler found out 3 out of the 5 points, L1, L2 and L3. It was left for the Joseph Lagrange to find out the other 2 Lagrange points, namely the L4 and L5. These points L4 and L5 are quite stable. Okay, and if at all any space city or space housing can come, it can come only in L4 and L5 region. This L4 and L5 region are called the Trojan orbits. Okay, and is there any orbit, anything that is tucking up in that L4 and L5? Yes, there is one Earth's orbit has captured one asteroid called Bennu, and it is parked in the L4 region. By the way, what are these points? Okay, suppose if you place place an object in L1 or L2 or L3, L4 or L5, these objects, and assuming that they are stable, okay, these objects will not go around the Earth. Okay, they will be orbiting along with the Earth, and they will be having the same period of a year as 365 days as the Earth has got. So the objects placed in these Lagrange points, they don't have any independent movement. Okay, and they are pulled along by the orbit of the Earth. So in fact, we can say that they are piggybacking on the Earth's orbital velocity. So that's it. So what is there in the L1? In the L1 region, from the L1 region, you can observe the sun uninterruptedly for all the 24/7 and 365 days. So NASA has parked a satellite there. It is called the SOHO, Solar Helio Observatory satellite. Okay, and India has parked a satellite there, and it is called the Aditya L1. Okay, that point, L1 point, is ideal to observe the sun. And what is the L2 point ideal to observe? Since we are in the night side of the Earth, in the L2 orbit, and we not having any disturbance from the sun for all the 24/7, 365 days. So that from the L2, if you are going to place some astronomical telescope in L2, that astronomical telescope will be having an uninterrupted view of the universe for all the 24/7 into 365 days. Okay, previously NASA had one satellite parked there in the L2. Now they have parked James Webb Space Observatory. This James Webb Space Observatory observes the universe in the infrared light, and it is looking for the light that originated from the Big Bang region to understand the origin of the universe better. So L2 region is ideal for astronomical observation. For L3, as I said earlier, NASA doesn't have any plans for that L3. But still the science fiction writers have got a very good use for the L3. So leave the L3 now. Okay. And L4 and L5 are called the Trojan orbits. And these Trojan orbits, they are fairly stable. And as I said to you earlier, Bennu was one asteroid that was captured by the Earth's orbit, and it is there in the L4. L4 and L5 you can find at the 60-degree angle within the Earth-Sun orbit. So in effect, if you plot the equilateral triangle between Earth and Sun, and one of the vertices, that is, one vertex will be the Earth, another vertex will be the Sun, and the third vertex will be the L4 and the L5. Okay, so that is it. So since this is the mathematical construct and which is observed in the universe also, these Lagrange points are there applicable between any three objects. For example, there is a Lagrange point between Earth and Moon orbit, and in the L4 and L5 regions of the Earth Moon Lagrange points, so we have found out the dust clouds in the L4 and L5 region of the Earth and Moon Lagrange points. Likewise, in the L4 and L5 region of the Sun and Jupiter Lagrange points, you find hundreds of asteroids, meteors, etc. captured by the orbit of the Jupiter orbiting the Sun with the same period of the Jupiter. So this is the Lagrange point. Every major planet and sun in the Earth-Sun system has got the Lagrange points. So by the extension, these Lagrange points should be there everywhere in the universe, between two stars or between two galaxies. Everywhere you should be finding these kind of Lagrange points. And what are the practical applications of the Lagrange points? These various Lagrange points could be used as a place to store your fuel to fuel your rockets for your intergalactic travels. Okay. Now these are the uses of Lagrange points. And once again, if you find this video useful, and I request you to subscribe to my YouTube channel. Thank you. We will be seeing more of such videos in the future. And all these Lagrange points were constructed by the mathematicians. And without the mathematicians, these Lagrange points we will not be able to understand, we will not be able to use. So our heart goes for the mathematicians like the Leonard Euler, Joseph Lagrange, and several others. Thank you. Wish you all the best. Bye.